Alright, so today we're going to be taking a look at the beginning problems in Chapter 11. So you need your math book, your toolkit, a pencil, and probably a highlighter. So hit pause if you need to get those items. We're starting with problem 11.1, and it says, in previous lessons you determined that simple interest grows at a constant or a linear rate. That is, by adding the same amount each time, the x value increases. So when you're adding the same amount each time as the x value increases, we're talking about linear growth. The compound interest grows by multiplying the same amount, or an exponential, each time the x value increases. So the difference is linear growth makes a straight line, and the exponential growth makes that curve. You explored that in science class with the bacteria growth, and we also explored that in Chapter 10 with the baseball card problem, where each time they were increasing the value of the baseball card by 50%. So, part A says, what is changing in this equation? We're looking at the equation y equals x squared, and we want to make a prediction. What will the graph look like? So go ahead and write down your prediction. Part B says, create a table like the one next to all of the questions for the rule y equals x squared. So we're going to not do all of the values that they have. We're going to eliminate the -5. So we're going to do -4, -3, -2, -1, 0, 1, 2, 3, and 4. Go ahead and copy down this table. And our rule again is y equals x squared. So we're going to input all of the x values in for the x, and we're going to square them, which that means we're going to multiply them by themselves. So all of the negative values are going to be multiplied by another negative, which would result in a positive value. So -4 times -4 gives me positive 16. -3 times itself is going to give me 9. -2 times itself is going to give me 4. 1, 0, 1, 4, 9, and 16 is what's going to result. So then, based on this table and any patterns that you see without graphing yet, I want you to make another prediction. Do you predict that this equation is linear? Will it make a line? Why or why not? So now we're going to get ready to graph. You need your toolkit open to page 84. Alright, so this is what page 84 is going to look like when we're all said and done. And some things I want to point out is that I set my x and y axes up so that they were in the center of the page, because I need to go from -16 to positive 16. I also need to go from -5 to 5. So the graph that we just looked at is the parabola right here. Okay, that is the y equals x squared, and it is called a parabola. So you want to write these notes down. Here it is spelled nice and big. I know it's nice and small in my notes there. You want to make sure you add that to your toolkit entry. And go ahead and take the table that we had, and we're going to graph those points. So you should have 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, 3, 9, -3, 9, and then 4, 16, and -4, 16. When you connect those points, it should be a fluid motion and make this nice fluid U shape, not a straight, like it shouldn't make straight lines from the points to the next points. Alright, so let's talk about some of these notes I have written here. We have that it's nonlinear because it does not make a straight line. It's exponential because of the exponent in the equation here. And it's non-proportional because from each of the y values, it doesn't change by the same amount each time. And I want to point out one more thing on here, that I named each of the quadrants as we go. Okay? So the next equation that you should be looking for, or the next video, should be the cubic function video. I take that back. We have one more graph here to do. So we have the bottom graph, y equals negative x squared. And what happens when we do this one is that if we have negative 3 and we input it, it does result in positive, or not positive 3, it results in positive 9, but this negative on the outside makes it negative 9. So all of our negative inputs are going to result in negative outputs, as well as, that's a 0, as well as our positive outputs are going to result in negative outputs. And so we get the upside down U-shaped parabola. Now you're ready to look for the video on cubic functions.